All right, so today I'm going to focus on an area that I truly enjoyed throughout high school, and that's geometry. Today's topic is going to be segment addition postulate. That's what it's called. I'm going to give you the spelling in a second. It's real easy stuff, but it's called segment addition postulate. All right, so there it is, segment addition postulate. All right, segment addition postulate. So before I get into the segment addition postulate, I want you to get the concept of what's going on here. Just imagine these are a pair of shorts, and these are the back pockets right there. And you know that this person has $17 on their person, right? They have $17 total. But here's the shorts and here's the pockets. Now, if I gave you one of these amounts, like if I said, okay, this person has $8 in their right pocket, how many would they have? How much money would they have in their left, right? And that's pretty much a really easy concept to grasp, right? So we got $17, 8 in the right pocket. How many is in the left? It has to be $9. Because pretty much if you add these two pockets up, you'll have $17. That is the same idea that we do when we do algebra. This is the same idea that we do when we use segment addition postulate. Now, to figure a problem like that out, you actually don't have to draw a picture. But the point is, because geometry is visual based, right? A lot of this stuff has to do with shapes and things like that. Sometimes we use diagrams to explain the same thing that you would have to do on paper anyway. So we're going to look at another visual representation of this same problem. All right, another visual representation of the same problem, this time using segments. All right, so what I have here on the board is a segment AB. Now I'm going to break this up and just put a random point here somewhere in between and call that C. All right, so now I have a segment AB with a point C somewhere between A and B. Your first goal is to be able to identify your parts. So the first thing I identify is the whole segment. This is the segment name from start to finish, from A to B. So I call that segment AB. Now, segment AB happens to have a point C somewhere in the middle between A and B, right? So what that lets us know is that if I go from A to C, segment AC, and I add segment C B, you have to excuse that. Let me rewrite that. If I add those two pieces up, I get the whole segment. I add the pieces up. So in geometry, that same story about the money in the pocket, I'm having $8 in my right pocket. How much do I have in my left? If you know that this person actually has $17. This is the same exact thing. This is just a geometry approach. This is geometry vocabulary. So it uses a lot of ifs and thens, ands, or stuff like that. Like it gets you to thinking logically now. So if I'm telling you that the whole segment is 17, which is from A to B, and then I'll let you know that B is 8, which is from here to here, then how long is segment AC, which is here? So the best thing to do is to label your diagram with all of the correct measurements. That's what's going to help. Now I'm going to start off by showing you how to use the diagram. After I show you how to use the diagram, then you're going to see how we use the statement. Either or works, all right? But at some point in time, we have to start being able to use statements. That's the goal, to be able to use a diagram. But if that diagram is gone, we have to be able to use statements. And there it is. Notice how the whole segment is 17. Then I put an 8 on the part where the 8 should be. So by addition, or if I did subtraction, if I take away 8 from this 17, it's going to leave me with this, which is 9. And what that lets me know is that 9 plus 8 is 17. That's how we use the diagram. That one could be done mentally, of course. Now, if I'm going to use the statements, all I'm doing is everywhere I have a segment labeled, if I know what that number is, I put that number in that spot. If I don't know what the measurement is, because remember AC was the segment that we were trying to figure out, I use a variable, I use a question mark, I put a blank spot there, a box, whatever. I just put a placeholder there, and then I continue on throughout the problem, and I fill in the rest of the numbers that I know. So using the statements, what I have here is 17 is equal to something plus 8. Now, just to get people, in line with what we do in algebra, we like to inverse our operations. So I use subtraction to get rid of this addition. So if I keep everything balanced, if I subtract 8 on the left side of the equal sign, I have to come over to the other side of the equal sign and subtract 8 over there also. Now, because these are opposites of each other, they cancel out and give you a 0. Now I can drop this x down, and now I can do subtraction. Same subtraction you've been doing since elementary. 17 minus 8 is 9. So what that lets me know is, as a matter of fact, instead of using in x, I could just use AC and just drop down AC. There it is. I could do it like that. Either or. But there it is. Your missing variable or your missing segment is 9. Same thing, using the segment. Really, that's the only example I really want to go over, just so that you understand the concept of how you set up a problem using a segment. Tomorrow, I'll probably do more medium level problems that use less information and more variables. But either way, that same technique that I use where I labeled everything and then I put in the measurements that I did know, that is going to apply no matter how complicated the problem seems. All right, so you can find me on YouTube. You can search right there, BJ Jeffries. That's the spelling right there. Look for this picture here. That's where my channel is. I'm uploading videos each day. I report to work. Like, share, subscribe, drop comments, whatever you need. But yeah, that's my channel right there. Find me on YouTube.